We are from Al Marifa International Private School, Thermal Physics, IGCSE 0625. Our learning objectives: 2 to 3 thermal physics, thermal capacity or heat capacity. We are in supplement side, use the terms of latent heat of vaporization and also latent heat of fusion. Also give a molecular interpretation of latent heat, also define specific heat, specific latent heat, and the last one, describe an experiment to measure specific latent heats for steam and for ice. The last one also recall and use the equation energy equal ml. So what is latent heat? As you see here, I'll start explain the latent heat through the stages of change of matter. So as you see here, the stages from gas to liquid, condensation, liquid to solid, freezing, also from solid to liquid, melting, from liquid to gas, boiling. Now, as you see the phases, water has 3 phases or states: solid, which is ice, liquid, and gas, steam, or water vapor. Now, the latent heat, as you see here, the graph of change in a state after heating this cube of ice. We will have this graph. As you see, the temperature increases, so the state of the matter changed. And in the x-axis we have the temperature in Celsius. In the x-axis we have the time interval. In the y-axis we have the temperature in Celsius. And as you see in the graph, we have this section or this part, this segment, where the temperature is constant for some time interval. And we name this period by the melting process. And the state of the matter in this period or segment that is shown by this arrow is solid and liquid. And the temperature at that time for pure water, it is 0 Celsius. So at this point, the ice continues to absorb energy, but the temperature does not change. The temperature in this case is constant. So the energy absorbed is called latent heat of fusion. So it is needed to separate the particles and weaken the intermolecular force between molecules. And as you see, the potential energy increases while the kinetic energy is constant, since the temperature is constant during this period. So the energy is released again when a liquid changes back to a solid. So in the inverse graph, if we will start from liquid into solid, so the energy, same amount of energy will be released to also back the state of the matter from liquid into solid. Now the specific heat, latent heat of fusion for ice, as you see here, it is 330,000 joule per kilogram. Now, what is the meaning of this number? So we need 330,000 joules of energy needs to transfer to change each 1 kilogram of ice into water at the same temperature, which is 0 Celsius. This is the meaning of this number, which is latent heat of fusion. Now, in the equation that we need to learn and to use, energy transferred will be equal mass times specific latent heat. So E or Q will be equal ml. So since this is about, this is the general equation, since we are talking about latent heat of fusion, so E will be equal mlf. For example, if we have 3.5 kilograms of ice and melted at 0 Celsius. So E will be equal ml. Energy transfer will be equal mass, which is 3.5 kilograms, times the specific latent heat, which is 330,000, and the energy supplied will be equal this number, 1,155,000 joules. And this is the solution of this example. Now, how to measure the specific latent heat of fusion of ice? And this is the requirement experiment. We need it in IGCSE. As you see, what are the apparatus we need? We need the heater, immersion heater, which is 12 volts power supply. And we need also crushed pure ice, and we need a funnel, we need beaker, and we need melt water. Now, as you see, what is the requirement of equation we need? We know that we need energy is equal power times time, since power is equal energy over time. So we need this equation to use it. Now, 100 watts immersion heater switched for example, 30 seconds. Now, mass of water calculated will be equal 0.10 kilograms. This is example of data that we can collect from this experiment. So the summary of this experiment will be E will be equal M times L. So we need to measure L. So we have to rearrange the formula. So L will be equal E over M. Now, since E will be equal 100, for example, 100, which is times 300, which is the time that is taken. So 100 times 300, this is the energy. As I said, we have to use this equation to measure the energy, which is equal power times time. Then L will be equal this amount, 30,000 over 0.10. So the latent heat will be equal 300,000 joule per kilogram. To melt 1 kilogram of ice, we need this amount of energy, which is 300,000 joules. So this is the summary of the experiment we need to learn about. Now, as you see here, only an approximate figure for L, as no allowance made for heat loss to the surrounding. We have this note. So this is how to measure the specific latent heat of fusion. Now the second one is latent heat of vaporization. As you see here, we have water boils at 100 Celsius and producing steam. Now, if the kettle is not switched off, more thermal energy is absorbed by the water, producing more steam at 100 Celsius. Now, as you see here, the energy absorbed by the water is called latent heat of vaporization. So, as you see, most of the thermal energy is needed to separate the particles and weaken the intermolecular force, so the water will change into gas. So some energy required to also push back the atmosphere as the gas forms. So this is the latent heat of vaporization, is the amount of energy that is needed to change 1 kilogram of water into from liquid state into gas state. Now, the specific heat, latent heat of vaporization of water is 2,300,000 joule per kilogram. So what is the meaning of this? So the meaning of this is that we need 2,300,000 joules of energy to change 1 kilogram of water into a gas or steam at the same temperature of 100 Celsius. Now, same equation as before we will use, which is E equal ml. But to distinguish between latent heat and of vaporization and latent heat of fusion, we can say that E will be equal now M times LV. LV is the latent heat of vaporization. Now, the experiment that we need also and required in IGCSE to measure the latent heat of vaporization. The apparatus that we need electrical heater, and also we need water. We need also mass balance. As you see also, we have to remember that we need to use this equation to measure the amount of energy, which is power times time, since power is equal energy over time. And also see, this is an example of data collected by the experiment. So we need 100 watts. This is the power of the immersed heater. And it is switched on for 500 seconds. The mass of the water, suppose it is 20 grams. We know that E will be equal ml, L will be equal E over M. Now, to measure the energy, 1000 times 500, the power times time, and the answer will be 550,000 joules. Now, to measure the latent heat, as we said, we have to rearrange the formula. L will be equal E over M. So L will be equal the number calculated in the previous step, which is 50,000 joules over 0.02. And the latent heat of vaporization in this case will be equal 2,500,000 joules per kilogram. So this is the latent heat of vaporization that is calculated in this practical experiment. As we say before, only an approximate figure for L, as no allowance made for heat loss to the surrounding. And for this point, we have a lot of questions about how to improve to not lose any of heat to the surrounding by using insulating material. So this is about the experiment that is required for latent heat of vaporization and latent heat of fusion. So latent heat of fusion is the amount of energy that is needed to change 1 kilogram of ice to melt it into liquid and melting. And latent heat of vaporization is the amount of energy that is needed to change 1 kilogram of liquid into gas by boiling. So this is the two experiments, and also we have to compare between the latent heat of vaporization and latent heat of fusion. This is the end of our session. Thank you.